Hi students, welcome to my lectures. So far we have done estimations of volume using pressure and temperature data for liquids as well as gases or vapors. So we are done with the chapter and we are moving towards heat effects and entropy effects. That means in thermodynamic systems there are a number of things that comes in place when we talk about finding the feasibility of a process. It requires the values of enthalpies and entropies. So we have to get familiar with those kind of equations to estimate the enthalpies and entropies in various situations. We are going to discuss in the elaborative way in the next lecture. I will give you the glimpse of example. Enthalpies are of two different kinds. One is how much amount of energy transferred. That means, example, there is a system with state 1 and state 2, and if you are trying to change bringing the system from state 1 to state 2, how much amount of enthalpy or how much amount of energy associated with the process you can able to estimate using two different kinds. One is sensible heat, second is latent heat. Wherever there are because of the changes in the process, a temperature is changing. So for those kind of process, we have to measure the enthalpy in terms of sensible heat, and sometimes we require to find out. And there is a process that involves a phase change. That means, example, those phase change process occurs at constant temperature, because you cannot measure the energy involved in the process by measuring the temperature, because during the latent heat of vaporization temperature won't change. For example, water at a liquid at 100 degrees centigrade, if you provide more heat to the system, it will become a vapor. So during the vaporization process temperature will not change. During that process you cannot measure the energy, you cannot calculate or estimate the energy in terms of change in temperature. Those kind of things which does not involve the change in temperatures, you have to estimate the enthalpies in terms of latent heat. And sensible heat are those in during the process, if you can able to detect or temperature changes for those kind of energy interactions, the particular heat effects is called the sensible heat effects. And sensible heat effects could be many things, because there might be cooling, there might be heating, there might be reaction that is happening which can bring the temperature changes or energy interactions. There are different equations associated with it. Okay, this is what we are going to discuss in the next subsequent lectures. Okay, and there are number of terms that is going to come in the process, so that you can able to make sure you get familiar with the equations, like what is integral CPH, what is ICPH, what is MCPH, what is IDCPH, what is MDCPH, because these are the equations that goes into the calculations. And the other thing is, in line with the heat effects, we also need to find out the entropy effects. Whatever the heat effects entropy equations are listed in the previous, this particular material and this material, we are trying to see only for the ideal mixtures, which is ideal gas. Okay, whatever equations you are seeing, everything is applicable for the ideal gases. So there are equations available for the non-ideal conditions as well, that we are going to see at the later parts of the stories. So let us get familiar with the ideal equations to measure the change in enthalpies and change in entropies associated with the process. Just like the kind of enthalpy changes, because you're taking the system from one state to another state, during this change of state, there might be changes in the entropies. So how we can able to calculate? During heating process, how the entropy is going to change. During the reaction, how entropy is going to change. During the phase change, how the entropy is going to change. All these things we are going to calculate. Okay, so to do that, there are similarly the enthalpy, there are specific equations exist. For entropy also specific equations and terms exist, just like the case ICPS, MCPS, IDCPS. Okay, these are the terms which are going to come, just like that of enthalpy. If you see the enthalpy, ICPH, MCPH, IDCPH, these are the things. For for the entropy, ICPS, MCPS, IDCPS, these are the things associated kind of equation that comes in play. Okay, before we start this enthalpy and entropy things, let us take a because first of all you should get familiar what is delta S and what is S. This kind of, there are some terms and terminologies that are existing, so let us get familiar before we actually enter into the topic. For example, heat effects. When you talk about the heat effects, for example, there is a substance contained at certain temperature T1 and P1. You are supposed to calculate what is the enthalpy of this particular substance at the state 1, which is at T1 and P1. To define the enthalpy of the things at this particular state, you need to take the help of the reference conditions, because to get to know the enthalpy here, then you should know what is the reference point where you are measuring this enthalpy. The reference point depends upon the data availability. You can choose your own reference points. So to define the enthalpy of this particular substance at the state 1, which is at a temperature T1 and P1, you should take the help of reference. So the reference pressures and reference temperatures are subjected to the availability of the data. So sometimes these are already provided. Okay, if you know already what are the reference conditions, let us say PR is the reference pressure or P0. Sometimes you get to see the notation P0 and PR. Sometimes you get to see the temperature TR and T0. So the reference things you should know. Then only you can able to estimate the state 1 enthalpy from the reference states. Example, there is a substance which is at a state 1. You are supposed to measure the enthalpy. Then you should get idea of the reference state. From the reference state, how much amount of enthalpy is added to get to the state 1, that is what the delta H. The difference between the reference enthalpy and the state 1 enthalpy is nothing but delta H. That means wherever you see the delta H concept, that means there are something to do with the difference. How much enthalpy between the reference state, the difference in the enthalpy at the reference state and enthalpy at the state 1 state, that is nothing but delta H. Delta H nothing but H2 minus H0. Here H0 and HR are reference state enthalpies. It is represented by H0 degree. You can see the kind of circle is available at the numerator. If you see this kind of conditions, that means the top circle on the enthalpy, that is H0 power superscript 0, that is you are trying to measure at standard pressures. Generally the data available at pressures which are at 1 bar. That means that the degree here is denoting the enthalpy which at the reference state is at a pressure 1 bar. Okay, because generally we have to start at certain reference conditions. Generally pressure people will keep at 1 bar while measuring the reference states. Okay, so what is the difference in enthalpy of the reference state and the state 1 is nothing but delta H, which is H1 minus H0. So in generally, if there is a no phase change, it is only the temperature that is different from the reference temperature, because reference temperature is TR and the state 1 temperature is T1. So only the difference between these two are the temperature itself. Then you should add this particular enthalpy to this reference state to get to the state 1. So H1 is the enthalpy at the state 1, H0 is the enthalpy at the reference state, delta H is nothing but H1 minus H0. So the difference in enthalpy is nothing but integral TR to T Cp dt. What is TR? That means for you to measure the state 1 enthalpy, you have to change the temperature from TR to T1 at some specific heat capacity value. So the difference between these two is nothing but integral TR to T Cp dt. And these are all applicable for the ideal gases, remember, whatever we are doing. So if delta H equal to, which is H1 minus H0 integral TR to T Cp dt, then what is the enthalpy at the 1? Enthalpy at the 1 as at the state 1 is H0 plus integral TR to T, okay, TR to T Cp dt. That means to get the value of enthalpy at state 1, you should know what is the enthalpy at the reference condition plus the difference between these two. That is difference between these two, which is TR to T Cp dt. So this is how you should able to get the enthalpy of any substance at a particular temperatures and pressure. And you can see if you compare these two, it is at a different pressure and it is at a different pressure. Where is the pressure variation we have brought? You see there is only temperature variation has brought into the equation. Pressure variation did not brought into this equation, because as far as the ideal gases are concerned, okay, you don't need to worry about the pressure. Enthalpy only depends on temperature, not on the pressure at which you are working. Even though the reference pressure is P0 and the state 1 pressure is P1, you don't need to worry about the pressure, because pressure effect on the enthalpy is negligible compared to the pressure effect on temperature. So in the equation, you are going to see the enthalpy only depends on the reference temperature and the final temperature, which is T1. So let us do a small example. Let us find out an example. It's a crude, it's a very simple example. Don't worry about that, what substance I have taken. Simple. I have to measure, example, in this particular container, I have water, which is at certain pressure, 1 atmosphere and 50 degrees centigrade. If water is present in this system at this specific temperatures and pressure, then what is the enthalpy of water at this 50 degrees centigrade? So to do that, you should know the following things: initial temperature, which is T1, reference temperature also. So it is provided that standard reference enthalpy, okay, standard enthalpy water at reference temperature is 25. In general, enthalpy of substances provided at 25 degrees centigrade and 1 bar pressure. So pressure has no effect, don't worry about the pressure. So the given is standard enthalpy of water, that means enthalpy water at reference conditions. The reference conditions which are at 25 degrees centigrade is provided is minus 285.3 kilojoule per mole. That is nothing but minus 285.83 into 10 cube joule per mole. So I know how we got this value. This is small homework, okay, please do it. How people calculate the reference enthalpies. Okay, if you refer to any kind of AI platforms, ask, just curious. If you are curious, find out how a reference enthalpy is calculated for any substance at a specific temperatures and pressures. Then you will get an idea. So let us assume that I have got the value of the reference enthalpy. Now Cp of water is 75 joule per mole Kelvin. Now I have got everything in place. Simple, I have to substitute in this particular equation and find out the enthalpy of water at the state 1. It's simple. Substitute each and every value. Integral I have to take from 25 degrees centigrade to 50 degrees centigrade. Always remember, don't use degrees centigrade, because of course finally you are going to find out the difference. There is no issue, but it is always, I recommend you, wherever you see the degree centigrade, convert it to the Kelvin, then only you start calculating the things to avoid the major mistakes. Okay, so finally the enthalpy of water at 50 degrees centigrade is minus 283,955 joule per mole. This is how you can estimate the enthalpy of anything. Generally in thermodynamics, the actual enthalpy value is not important. Only thing is difference is important. This delta H, which is H1 minus H0, that is integral Tr to T Cp dt value. That means this particular value is sufficient in many thermodynamic calculations, because reference things will cancels out during the calculations. Only thing is important is in thermodynamics, you wanted to predict any aspect, the only important is delta H. So in this example, I have shown you that how to calculate the absolute value of enthalpy at state 1. Only you can able to calculate absolute value unless you know the reference state. You cannot calculate the actual state. You can see the H1, the enthalpy of any substance at the state 1. Unless you get the H0 degree value, you cannot able to calculate what is actual enthalpy. But difference in enthalpy you can always estimate. It is because of the temperature change, Tr to T Cp dt. I know the reference temperature, I know the final temperature, state 1 temperature, so I can able to get the informations of delta H. I hope you understand. Let us do the same example for entropy. Entropy effects. Similar example, there is a substance that is present at temperature T1 and pressure P1, which is at a state 1. And I wanted to estimate what is the entropy value of this particular substance in the state 1. To calculate the actual entropy, the same way, you need to know the reference entropy value, which is SR0 or S0 degree, SR degree or S0 degree, anything. Sometimes people use this particular notation, some people use this particular notation. Don't worry about it. So it is simple. At some reference temperature and pressure, I should know the entropy value. So what is the enthalpy, entropy of this particular substance at this temperature is nothing but delta S equal to S1, which is state 1 minus reference, which is S0, okay, which is nothing but integral Tr to T1 Cp dt minus R ln P1 by P0. Now you can see the pressure term has come in. What is delta S? To calculate the change in entropy from reference state to the state 1, you need to bring what is the temperature changes that has occurred as well as what is the pressure changes that has occurred. The pressure has changed from P0 to P1, temperature is changed from T0 to T1. So entropy, just like enthalpy, you cannot neglect the pressure, because for ideal gases, pressure is also play an important role in the difference in entropy. So the first term, which talks about the changes of entropy because of the temperature, the second term talks about the changes of entropy because of the pressure. So in order for you to calculate what is the substance, what is the entropy of this particular substance in the state 1 is nothing but standard entropy, okay, integral Tr to T1 Cp dt minus R ln P1 by P0. Okay, you can talk about it is T0 or Tr, anything is fine. It is also a T0 or Tr, okay, because I have used the same notation. So let us calculate. Let us find out what is the entropy of this particular substance in the state 1 by taking the small example. Given we have to find out the entropy of water at 2 atmospheric pressure and 50 degrees centigrade. Okay, that means a substance, water, is present. That means it is not a gas, of course, but for a simplicity point of view, I have taken an example so that you can be able to connect more. So there is a water that is presenting at 2 atmosphere and 50 degrees centigrade. I am supposed to find out what is the enthalpy of water. So to do that, I should know what is the reference reference entropy, because S1 to calculate, I need to take off the S0. Everything is given. So standard enthalpy of water at reference temperature. Reference temperature is taken as 25 degrees centigrade and the pressure is 1 atmosphere. That means these are the reference conditions. 69.9 joule per mole per Kelvin. Okay, this is what the standard entropy value of this particular water at this 25 degrees centigrade and 1 atmosphere. Now I know the things. I need to simply substitute in this equation. Okay, again this is a homework, that how people will calculate the standard entropy values. Here it is given 69.1 joule per mole Kelvin. You are supposed to get how this 69.9 came up with the standard entropy of water at this 1 atmospheric pressure or one atmospheric pressure and 25 degrees centigrade. So you use AI platforms, it will give step-by-step calculation that how any people can able to calculate the entropy, standard entropy values. So let us substitute S1. And that means entropy of water at 2 atmosphere and 50 degrees centigrade is nothing but standard entropy plus integral Tr to T1 Cp by T dt minus R into ln P1 by P0, a Tr or T0, okay, anything, reference one. And R into ln P1 by P0. P1 it is given 2 atmosphere, P0 the reference pressure value is also 1 atmosphere. And it is said that it is given that 69.9 plus Cp into Tr to T1 into 1 by Cp. If you assume the Cp is the constant, you can come out of the integration at any point of time. So if you because main complexity comes when the Cp is not a constant. For the simplicity case, I have assumed the Cp is a constant. It comes out of the integral. So integral Tr to T1 1 by T dt minus R into ln P1 by P0. The standard formula, which we are going to see how this has come up in the later part while we are discussing the fundamental property relations. There you are going to get this kind of formula, how we have got this particular formula. Finally, you substitute. If you Cp comes out, what is 1 by T dt is ln T. Okay, so 69.9 plus 75, because Cp is 75, into ln T1 by Tr minus R ln P1 by P0. I told you, right, you don't always you try to give in the unit, you have to maintain the unit consistency. Here the ratio of temperature is there. Whenever the ratio of temperature is there, it is always recommended to go for the mainly SI units. You can try to convert everything in the SI units and substitute. Take the temperatures in Kelvin. Okay, so that is why ln of 50 plus 273.15 plus 25 plus 273.15 minus 8.31 ln 2 by 1. Okay, if you convert, you also convert the pressure into SI units. Remember, that is, it is, otherwise you are going to do the mistakes. So once it is done, the entropy of water at 2 atmospheres and 50 degrees centigrade is 145.42 joule per mole Kelvin. This is how you have to estimate. Always remember that this is more important, delta S, than the S0, because in many of the thermodynamic calculations, the change in entropy is more important, which goes into the majority of the calculations. So that means this integral Cp by T into dt minus R into ln P1 by P0, which is nothing but delta S. Mainly this plays an important role. So whenever you wanted to calculate the absolute values of entropy, you should take the reference conditions. Then only you can able to calculate what is S1. Otherwise you can calculate the delta S only itself, depending upon the situations. Thank you very much. Don't okay. One more important thing, you get things clarified. Wherever you see the delta S, that means the difference he is speaking about. Wherever you see the S1 or S0 kind of, that means absolute entropy values we are trying to deal with. Thank you very much. Meet you soon.